everyone. Thank you very much for the invitation and the introduction. Today's talk will be building artist-centric tools and machine learning in production, and this is basically a how-to guide of doing research in the industry. I'm Miladi, the lead machine learning researcher at Cinesight, and Cinesight is a group of studios that offer VFX, animation, and visual services with studios around the world. Here are some of the productions that we've worked on in the past decade or two, some of which you might be familiar with, and lots that are not included here. While Cinesight has been around for quite some time, machine learning is a much newer area at Cinesight. We started looking more seriously into ML with me joining about a year and a half ago. We've been working on lots of different projects like rig approximation, using LLMs for database retrieval from our documentation database, and lip sync, and most recently motion in-betweening. I wanted to share some of our findings and some of our values that doing a machine learning work at Cinesight. Firstly, we don't use ethically questionable data sources in production. A lot of us at Cinesight are artists, and we don't want to infringe on the rights of artists, so that's a really important thing for us. And we also want to leave creative control completely to the artist. What has made this past shows amazing has been the creative control that the artists have had, and we're not planning to replace that by AI or machine learning it. And because of that, we want the output to be fully and easily editable. If the output of your models is not editable, if you're outputting final pixels, then the artists are not able to put their creative control over that. And we want to involve artists at every step of the process. This is tools that we're making for them, so we want to get their feedback at every step of the process. And before I go further, I just want to make a quick clarification. Some of you might have heard of TechX. TechX is a new unit at Cinesight exploring Gen AI for animations and VFX, and they explore a host of existing models, but they don't train any new models, just looking at existing models. And they operate independently from production, so the TechX is not being used during production, and what I'm talking about is about production, not TechX. Since we're talking about production, and I think it might be helpful to get a quick background over large-scale 3D production. I'm sure a lot of you are very familiar with that, but for those of you who are not, let's have a quick look. It's a very complicated pipeline with lots of people and lots of different roles, and all of them are been working on their craft for often decades or more. You have lots of different roles like concept artists, modelers, creature 2D animator, texture artists, and lots of different roles. And basically anything that you see on the screen, every strand of fur has been meticulously designed and iterated by a group of expert artists. And the larger these worlds get, the more challenging the artist's job can get. And what is often expected from artists in this situation is quite a lot. Of course, every show is different, but generally what's needed from the artist is to be comfortable with lots and lots of revision and feedback. In VFX, we have something called the dailies, where every artist show their work in a cinema room with lots of other artists, sometimes the director and sometimes the VFX supervisor, judging every frame and every pixel of their work, and each work often goes through lots of iterations and lots of feedback. And they need to keep in mind that anything can change at any time. There's been some very high-profile examples of this, like Sonic, where very last minute the full character completely changes, but it happens all the time, where suddenly at last minute the cape of the superhero might change, and artists have to go back in all the shots and fix that, which can be very challenging. And there's also lots of tight deadlines. The next big blockbuster is not going to be delayed because of the VFX, so the artists need to figure out how to make this work with those tight deadlines. And as I mentioned, it is a very highly detailed work and requires a lot of technical expertise as well. And the artists use very specialized software that is constantly changing, so there's a lot of learning involved in this as well. And the analogy that I quite like is it's a bit like riding a train and building the train track at the same time, which can be even more true for games, where you might be building the game engine as you're building the game. And staying consistent to art direction when you have thousands of artists, that is really challenging. Every single shot, every single asset needs to look like it belongs in the same world and follows the same art direction. And when you're coordinating thousands of people across different time zones and sometimes even different companies, that can get really tricky. And to get an idea of the complexity of VFX, let's look at this VFX breakdown from Witcher 3. And the words that we're seeing here, as I said, the larger they get, the complexity grows exponentially. Every detail that you see here has been meticulously designed by someone. So like for this character, we see very detailed models, muscle simulation, fat simulation, rigging, and we see lots of secondary character effects like the drool and the spit and the dust in the environment, and all of that has been done by expert artists. So as you can imagine, this is a very challenging work and extremely time-consuming and expensive. So as researchers, developers, how can we help artists? I'm sure you've all heard of generative models. They've been recently making a lot of noise. Now almost anyone can just type a few words and create this videos, images, music, and even books that might have taken some before weeks to create can be now created in a matter of minutes. And this could potentially be an answer to how can we improve the workflow, but why, if this is this amazing, then why haven't we seen it being used everywhere all the time? Shouldn't it change the industry any day now? And the reason for that was partially because these models early on were very rough. There was a lot of issues that have been getting better over time. Like some of these issues where they used to only work with text, and as you can imagine, you can't really make films by just typing some text. It's not precise enough of a control. But with recent models, we're seeing a lot of new ways to control these models. And they also follow instruction a lot better. A lot of the time, they would completely ignore your instruction, but now we're seeing they're getting better and better. And the physics and emotions were all very off and very unnatural. Like stuff would appear out of nowhere, blend into each other. People would walk really weirdly. And all of this stuff is very much there now, but we have making some huge improvements in there. And same can be said about the lack of detail and the resolution and the quality as well. Again, so much work to be done, but we are very far away from the days of those funny videos of Will Smith eating spaghetti. And with recent models, you can make short films like this. And this is the idea for this short film, is like aliens in the future, making a documentary about humans in the past. And it's really great. And like, even though there's lots of issues, like they sometimes get human hands, these aliens, and all these kind of like weird movements and a lot of like lack of details, but clearly this has come a long way, and presumably with more data, with more scale and compute, and maybe with better architectures, we can solve a lot of these issues as well. So then why are we not using them more? Like, what is stopping us from using this? Probably the most important issue being is that these models need to be trained on internet scale datasets, and that includes thousands of hours of copyrighted material, and that's ethically and legally a gray area, and nobody knows if you use generative models in your work today, can you copyright your work? And that's a huge gamble for studios to take. And putting aside the ethical and legal considerations, it's really difficult to make these models stay consistent across a 2-3 hours movie. Even with 1 minute short videos, it's really challenging to get consistent character looks, consistent environments, and no one knows how can we even possibly begin to scaling this into 2-3 hour films. And these models output final pixel, and as we said, like these final pixels are not very editable, and it takes a lot of creative control from the artist, and you can't really do highly specific edits with these models. And if you want to go and manually fix these issues, you can have to rely on traditional pipelines, and it can take as much time as starting from scratch, which makes using these models sometimes pointless. And they are a lot less creative than humans. A lot of what they make feels like a mishmash of things we've seen before, and that's of course true for humans as well. Like, that's how creativity works. We bring ideas from different places, but I think it's a lot more derivative what these models can make. So for example, going back to the alien example, if you were to ask these models make a completely new and unique and unsettling alien that no one's ever seen before, these models will completely struggle with making anything fundamentally new. But we've seen humans making completely new stuff that feels like very different to anything that we've seen before all the time, but that's not something that these models that are able to do. And they completely change existing workflows. Artists are used to 3D workflows and modeling, and now they have to somehow just try to do everything by using their boards, and that's not a very great workflow for them, and it can be really frustrating. And as well as that, these models can interpret the feedback as well as humans. Like we said, feedback is a huge part of these creative workflows, and we humans are very flexible with how we take feedback. We can say one word like this is tacky, or we can talk for an hour about something, or can show references from books, from music, from other films and videos, and we're really flexible with how we do this. But you can't do the same thing with these models. And a lot of these issues that we mentioned basically comes from the lack of control that we have over these models. You just have to type some words and hope for the best. And so what is the right amount of control? Like, clearly just typing some words is not good enough, so how do we give more control? Like early in the computer graphics day, the first 3D object was Utah teapot that you see on the left, and this was defined, they made this object by defining the 3D coordinates of every vertex or every point on this teapot, and as you can imagine, defining 3D coordinates is not very good for creative workflow, and you can't really make very interesting stuff this way. And we moved from that all the way to 3D softwares like ZBrush, where they gave you a lot more broader ways of controlling this, and you were able to almost make it feel like sculpting, and we saw people making amazing artwork like the one you see on the screen. And even though the task is still very manual, very technical, I think we've made a lot of good improvements. And even though you can make edits in broad strokes, you can still go in and edit every single vertex if that's what you needed to do. But from that, we've moved all the way to generative models on the right, and with a few words, you can make a scene like that, which is amazing. This would have taken weeks maybe to create for artists, but if you show this in production, there will be hundreds, if not thousands, of notes about the animation, the way the wings are moving, about the character look, and lots of other notes that none of it you can address with this generative models. And so it just doesn't work in pre-production, where you have high scrutiny over every single asset, over every single shot. And this can be really problematic, and not to say there's no use case for them. They can be useful in pre-production, where you might want to iterate through lots of ideas really fast, but because we don't have this flexibility to move back to different levels of control, the work you do in pre-production can be useless and just be used only as reference. So how can we add more control and flexibility to these models? There's been lots of people working on this, lots of research, lots of developers and artists. And there have been some really promising ways, like UI and UX. You can think of Comfy UI, where they provide a node-based environment, and because of this, now artists have been making very interesting workflows way beyond anything that the models were designed for. And very promising avenue also been training other models to guide the process, so like ControlNet, where you can condition the video generation process on a skeleton or an animation or depth data, and this gives lots of flexibility. And there's also been some avenues fine-tuning these large pre-trained models on a specific character or on a specific scene to add more consistency, or learning user preference through reinforcement learning, like we've seen with ChatGPT and some models like that. And also adding new features to these models like image in-painting and image conditioning has added a lot of good improvements. And finally, I think a very promising avenue has been mixing in traditional techniques. So the images that you're conditioning your generation on could be created in Blender, for example, where you get full control over it. And when you mix all these workflows, you can get some really amazing results like this person has made. This has been made using a mixture of these models and Gaussian splatting and a lot of other different techniques. And even though there are some issues like the cars moving backward in the road and the quality, still very great and flexible workflow where you can see the artist has lots of control over what they are making. And that's a huge improvement over what we had before. And even though, but this is looking really great, like there are some fundamental issues with these type of workflows that wouldn't work in production. For example, if you show that to an art director, they might tell you that the car needs to look more shiny in grazing angles. Like in traditional workflows, that's as easy as manipulating the shader. with a slider sometimes, but here, no idea how you could do that. You can try to describe it in the text and hope for the best, but you don't get any precise control over what you're making. And now that we've talked about how all the ways that it can go wrong deploying ML in production, how can we do it successfully? In short, it's pretty difficult, but let's get a better idea of why by looking at my personal journey with animation and machine learning. Animation as a craft has been around for quite a long time. The first examples of animation we have is this clay pot that was found in Iran 5,000 years ago, and when you rotate it, it makes this animation of this animal hopping. And if you think about it, 2D animation hasn't changed all that much. The fundamentals of it in all these years, we still make drawing a few frames, every few frames to convey this sense of motion. And you could kind of say that about 3D animation as well, even though it shares more roots with puppeteering. So if you think about stop motion puppeteering, it's very similar to how you would animate in Maya. And it's a very, even though we have these modern conveniences like undoing and changing the camera really easily, this is still a very manual, very high-skilled task. And my first experience at doing animation was in university, where everything I made, it looked awful. It had a horrible sense of physics, the timing was off, and it felt like really weightless and floaty. And of course, there was lots of people who made much better animations than me because they were more talented and they spent more time on it. But nevertheless, this is a very challenging task to do and very time-consuming. If you look at a professional's workflow by Mark Masters, this is an hour video to create this couple of seconds of animation, and this video has been sped up by like 10 times. So the actual workflow is about like 10 hours, a full day of work for this 2 seconds of animation. And in VFX, where you have lots of characters in the one scene potentially and have very high scrutiny on the quality, one scene can sometimes take a couple of weeks for an animator to animate, and we can see how easily this can become one of the most expensive part of the production because of the amount of time and expertise that needs to go in it. And the same thing can be said for facial animation as well. It follows a lot of the same principles, and because we look at human faces every day, all the time, we're very good at judging what looks off and what doesn't look off. And it can be really tricky to animate facial expressions. And one of the problems that the animation team at Cinesite came to us was that they were having some issues with the lip sync animations that they were creating. And lip sync animation is where you animate the face to match an existing audio recording from an actor, or and then that's like mainly animating the mouth, but also the full face to match this audio. And it can be super challenging to do this in a way that it looks natural and realistic. And this was something that we were struggling with. And so the quality and the consistency of our lip syncs was not very great. And one of the bigger issues was that for people whose English is their second language, it can be even more difficult to guess what facial expression that you need to make to pronounce something correctly. And because of this, we were having this massive inconsistency in the lip sync quality, and they reached out to us trying to find a solution for this using machine learning. We started looking at the literature. There was a lot of work in 2D and some in 3D, like this work from EA, where they directly generate these animations on a rig. And we took some inspiration from similar work, and we thought that, okay, now we're making this animation directly on the rig, so they are fully editable, and we are also using data-driven methods that can get a lot of the nuances of talking, which previous traditional methods missed. And that's where we started from. We started training some diffusion models that would take in an audio, and they would output this rig parameters for every frame of the animation data. And we thought we were on the right direction, and we presented this work to the animators, and we got very negative reactions, which took us a little bit of time to figure out why was that. But it totally made sense when we thought about it a little bit more. One of the bigger problems was the generated results weren't as easy as we thought to edit. Yes, technically they were editable because they were rig parameters, but because we were animating every single joint for every single frame, it was a little bit like editing that teapot. It was too much control. Like it's like you don't want to edit by moving control every single frame, and that was very difficult for them to edit. And the results didn't look good enough. I mean, we could say something was a little bit off about them, but to us it seemed almost there. But to the animators' eye, who are professional doing this day in, day out, it looked horrible. Like they thought like there is so much missing from these, and it wasn't as easy as we thought to fix these later on. And because of this, it was really hard to evaluate these results. Like generative models are famously difficult to evaluate since there are no good metrics to evaluate them. But now that we couldn't even visually evaluate them very well, this made our job quite difficult. And another big problem that we had was that the generated expressions didn't match the artistic direction that the directors would want. The work we were doing was for feature animation, and they a lot of the time have very exaggerated facial expression, and every animation can look very different. If you like look at some of the more recent examples where stylized animation is getting very popular again, and with each different style this wouldn't work, and which came to our next problem, which was lack of data. Typically these models would be trained on motion capture data, where you can have hours and hours of this data matched to an audio perfectly. But since we were working on stylized data, we needed to work with hand animation data. So the only data we could collect was from previous stylized shows. And there is not that many of this data available. And you might think a place like Cinesight, who's worked on all these production, would have plenty of data, but these are all owned by the studio, and there's very limited amount of data actually accessible to the studio to use for their own tools. And same problem we had was also for non-human characters and non-standard rigs. Because we were generating rig parameters, that meant all the rigs had to have the same structure and the same parameter give the same results on all the different rigs. This is easy enough to do for humans, but if you can imagine a crocodile, they have a very different facial structure. So the same rig that would work on a human can't work on a crocodile. And even if it did work, the same way a human would talk is not the same as a crocodile would talk in an animated movie. So this just doesn't work. And lastly, and probably most importantly, that we were told that the problem was not generating these animations faster, but the problem was knowing what face shapes to make to match the audio for animators to be able to raise the quality. So we were kind of approaching this problem from the wrong way. So we went back to the drawing board and say, how can we meet all the expectations that we have from the animation team? And the solution we came up with, instead of generating arbitrary expression for every frame, our model would use from a predefined set of existing facial expressions that the artist would manually create. And then these sets of facial expressions are the same across all characters, but they all have their custom expressions. So you can imagine, depending on the style of the animation, the mouth opening might be a lot more exaggerated or might be a lot more cartoony. But this way, since we are choosing from the same set of facial expressions, then we can make this model work on any style, on any character, on any rig, and that gave us a lot of flexibility that we were missing before. And as you can see, a lot of similarly sounding noises, they will make a similar facial expression, and that's why we can group these series of like sounds to the same facial expressions. And this was a lot more challenging than we thought to do. There was no existing work that would go from audio to facial expressions, especially a custom facial expression that we want to have. And there was no data for this as well either. There is no existing data anywhere for such a custom task, and we didn't have any either. We looked a bit more, and the closest thing we could find to this work was audio to phoneme models. And for those of you who are not familiar, phonemes are units of sounds, and you can basically break down each word to the units of sound that will pronounce that word. And we used a similar approach to that, and since phoneme and facial expression are a similarly related idea, we thought that could be our starting point. And because, again, like there was no data, we had to get very creative with how we do this. The only existing data was for audio to phonemes, and it only had 10 sentences in it, which, as you can imagine, is not enough for training machine learning models. So the first iteration of this, we started taking the dialogue from each character, running that through a audio to text model and get the transcription of the dialogue, and then we would use a standard phoneme dictionary to convert that text to the list of phonemes that would make up that word. And later another model would take that series of phonemes and would align it to the audio, so we have the exact timing for each of those phonemes. And later on we would take those phonemes and convert them to the facial expression that we have created rules for every phoneme, how to map them to facial expressions. This is not a perfect mapping, because depending on like previous phonemes or the phonemes afterward, the facial expression can change, but it's not exactly a one-to-one mapping, but it was good enough for STAR. But as you can imagine, this had a lot of issues working with this, and the biggest one perhaps was that here in the middle of this, when we are generating phonemes, we are completely discarding the audio, and that would mean regardless of how you pronounce the word, what accent do you have, or if you're adding any stress on any part of the word, it would just completely ignore all of that, and it would give you the same exact facial expression regardless of how you pronounce that word, which was a problem. And because of the lack of the data we had, also the accuracy was not good enough, and as well as the not perfect mapping that we had. Which brought us to the second iteration of this model. A big part of the problems here was also this 4-piece model. It was really slow to run, like you have to go from one stage to another. So we just kind of simplified the whole thing into one model. And you might be wondering, how did we train this? I just said there was no training data for us. And the way we did that was we took a Wave to Vec 2 model, which is a audio model already pre-trained on thousands of hours of audio data, so it's already familiar with human speech. And then we added a classification head to that model, so we can go from that audio representation that this model has already learned to the facial expressions that we want to get. And this classification head was trained on a data set that we labeled with the previous model. So we generated these pseudo labels with the previous models, and even though there were errors in that, of course, because the accuracy of the first model was not great, it allowed the second models to start learning more about what do we want out of it, how to map audio to facial expression. Later on, we used that 10-sentence audio data set to fine-tune this model, and that allowed us to go beyond the accuracy of the first model, even that small data set, because we already had a model that had a very good understanding of human speech. And this is where we currently are at. We are using this model we'll be using this model in our next shows, and even though the accuracy is not perfect, the great thing about this, as artists will edit the output of this model, we can then feed back to the model itself, and then we have this training loop where for each show these models get better and better, hopefully to a point that the artists don't really have to do much work to edit the output of them. Here's a screenshot from the first iteration of our tool. We have timelines for every character, an audio track that we have, and the model generates the initial version of this, and it puts these different facial expressions on a timeline, kind of like an editing software. And then an expert animator who's very familiar with lip sync could go over, fix these timings on the timeline, kind of like you would in an editing software. And because this is so much faster than animating, it allowed the same person to do the whole show, which raised our consistency and quality automatically, even without having to use the machine learning model. And then once the artist has made these edits, then this series of facial expressions will go to Maya for visualization for the animators to know what facial expression to hit at what frames. And you can either use the cartoony shapes that you see here, or you're also able to swap that for the 3D shapes that we have custom made by artists for every character. So then you get a rough animation that follows the style and art direction of every character. So the way that the director has imagined this character will talk will apply to the animations that we'll make here. And this experience really highlighted to us, like I've been working in animation and machine learning for 5-6 years. I thought I have a pretty good understanding of it, but it showed how easy it is to misunderstand what the artists want from you, and it's really important to keep them in the loop. And there are, I've had, from my years in research, I have had takeaways that I hope that it helps your research as well. Don't be fooled by cool demos. We see cool demos of machine learning models all the time, and they look amazing. But there is a lot of research and engineering that needs to go into actually applying these models in production. So to give you an example, deepfake like that, if you were to look at the demos from deepfake, they've been looking pretty much perfect for a few years now. But if you were to apply deepfake in production now, you would see lots and lots of issues that you just never thought about that arises, like motion blur, occlusion, different lenses, different lighting, all these different conditions that, like, when you want to do this in production and make an artist-friendly tool, it becomes very, very, very complicated very fast. And don't underestimate the importance of good UI and UX. Like, I think comfy UI should be a great lesson for all of us. Like, by providing this good UI and UX, artists are creative people and they can go so much beyond what you imagined the tool could be used, and providing that flexibility in UI and UX is very important. And as we said a lot of the times, editability is non-negotiable. And if the output is not editable, then it needs to be perfect, which is basically impossible. And try to find the right balance between creativity and control for your application. Is really important to provide the right level of control. You don't want to provide way too much control to the point that it becomes really frustrating to work with, or take so much control away that they're not able to achieve that. And I think even more important than finding that right balance is providing some flexibility for the artist to move between these and let them choose how they want to do this. And consistency and predictability are very necessary. Outside of character consistency, it's very important for these tools to be predictable. So if you can't expect what your tool will do, then you can't really work with it. Like, you can imagine a hammer that every time you use it, it puts a random amount of force on something. Then it will be really difficult to use this for any actual work. And I can't stress how domain knowledge is underrated. Any domain that you work on, try to learn as much as possible about it. There's been so many times during these times that we faced a problem and try to solve it with really fancy ways, but at the end we realized there was a much simpler, much cheaper way to do this, and people have been using it for many, many years. So try to understand the domain as well as you can. And probably most importantly, get constant feedback from your user or whoever, users or artists, whoever is going to be using that tool. If it doesn't work for them, then it just doesn't work at all. And I hope if there's one thing you take away from this talk is to listen to artists. Don't think you know better than that and better than them. And I think my experience has showed is how easy to misunderstand what the artists are looking for. So it's really important to get constant feedback and listen to them. And thank you very much.
Brilliant, thanks very much. I can't think I've enjoyed a talk that much for a very long time. Really fascinating. So now we've got some time for questions. So if you're in the room and you'd like to ask a question, just stick your hand up and I'll pass you the mic. If you're online on the stream, I guess put your questions either in the Q&A box or in the chat, and maybe Alan will keep an eye on it, and then I can read out those questions. So who's anyone in the room initially want to ask a question? Brilliant, I'll pass it over.
Hi there. First, I'd just like to say thank you for bringing up the ethical concerns as point one. That's always been an issue for artists dabbling with this kind of tech. My main question is, you did mention that stylized lip sync has a very, very limited data set to draw from. As you're progressing through this generatively, are you able to use the data that you create that artists approve of and the productions approve of for future generations of this, or is it locked away by exclusivity clauses?
Thank you for that question. That's a really good question. And yeah, as you mentioned, we have very little data. A lot of this data is owned by the studios. But since we are not, for this tool, the data we will be collecting is basically a series of timelines and phonemes. And that is not something that we have any issues. So that is part of our plan to, every time that artists make an edit to the output of this model, then that can be used as feedback for the model to keep making it better and better.
On his, because it
Oh, brilliant. We got one more from Heather.
Thanks for that. I really enjoyed it. I had one question around copyright, because you were talking about the fact that if it was an internet-based LLM, then how could a studio protect or own the copyright? Have you got any ideas as to how you get around that? Are you having to provide all of the imagery in-house, or are you using Creative Commons licensing, or is there a way that you can think about getting around that?
Yeah, that can be really tricky to do. Like, I guess the big problem with that is like the models we use in-house are fairly small, so they don't need that much data, so we can get around that. But if you can think of like ChatGPT, VO3, these are very, very large models, and you basically have to train them on all of internet. It's not, current iterations of these models just need that much data to be as good as they are. There are some companies that claim we don't use copyrighted data in their training, but I very much doubt that claim. It's just kind of a, I guess, legal gray area. I mean, we've seen companies like Netflix already experimenting with this in their TV shows, but since nobody knows what's the like legal implications of this, like it's kind of a bit of a wild west right now, just people trying and see if they will run into any issues later on.